So you'll recall that we talked a little bit about how business rules in the organization define the activity models and the structure models that are in place, and then we're able to use both of those combined to come up with our business process models. And we created some activity models. A business process model is a specialized type of activity model. Today we're going to take a look at the structure model side of things. You need to know how the data, the information is going to be structured in your business process as well. What is a structure model? Basically, in a business process, it describes for the business process the data and information structures. Well, what do we mean by structures? Well, we'll get into that in just a little bit. So you can think of the structure model as being kind of a blueprint, if you will, for developing the data files. And in most cases nowadays, that means the databases. Those databases are generally relational databases. That's a relational database management system. And relational databases are the databases that accumulate transaction and transaction-based activities for ERPs. And the structure model helps us figure out how to use of the database, how to use the database after it's in place. We've got a structure model that defines how the data, the information in the business processes is going to look. It gives us a blueprint for building the databases and helps us figure out how to use these databases after they're up and running. Purpose of structure models. They're going to describe the information entities. And what do we mean when we say entities? Well, we'll get to that in just a minute. In our domain. So the domain is just basically the scope of interest for the business processes we are investigating. So we've got the structure model. It describes the information entities. It also describes the relationships. Between the entities. Also, as a piece of describing this relationship, it also describes how many instances of one entity can be related to another. So how many instances of one entity can be related to another entity? and more precisely another instance of another entity. And then finally, in addition to just the entities themselves and the relationships, we describe a lot more about the entities. And we call those additional pieces of information the attributes about our entities. So the attributes are basically the characteristics of our entities. And we can see what we mean by that in just a few minutes, but basically we're talking about if we've got a customer, well, some of the attributes would be the customer name, the customer billing address, customer shipping address, and so on down the line. So the commonly used structure model in use today relies on what we call UML. And that's the Unified Modeling Language. And UML has been designed to be usable by both regular business people and systems analysts, and for that matter, developers, systems engineers, and so forth. So we've got what we call UML class diagrams. And they've got their own notation for structure models, and the specs for UML are maintained by that object management group. They should sound familiar because they're also the group responsible for the business process modeling notation as well. So this object management group is a not-for-profit consortium of experts in the area, from business, from regulatory bodies, other types of industry members from around the world. And UML also has notation for other types of diagrams. Other types of structure diagrams for that model. Then you can set up UML for testing systems, developing use cases, other types of behaviors for systems and business processes, different types of interaction diagrams. So there's all kinds of documentation that can be done using UML. But for today, we're going to be thinking about class diagrams. And what they do is they describe the logical structure of a database. So what do we mean by the logical structure? Well, the logical structure is how you and I think of the database, how we're going to investigate it, how we're going to think about posting information to the database. And the physical implementation of that might vary slightly from the logical structure, or it may mirror it exactly. So we're not too concerned, unless we're going in and really auditing in detail the database itself, the physical structure. All we're concerned about is how we think about getting data into and out of the database. All right, so for UML class diagrams, like everything else, we've got some building blocks that we want to use, just like we would for business process modeling or even old-fashioned flowcharts. So in a class diagram, well, we start with a class. What is a class? Well, a class is basically a collection of things. And we need to be able to separately identify these things. So separately identifiable. I'll go back to a customer so we can identify separately different customers that we have. And we as the organization wants to collect information about them. All right, so we've got all kinds of different classes. We're going to have customers, we're going to have vendors, we're going to have inventory items, we're going to have bank accounts, we're going to have employees. For the various classes that we've identified, we want to set up associations. How are these various classes related to each other? So we've got classes, we were starting to figure out how they're related to each other. And then in these relationships, we've got what are called multiplicities. Multiplicities are basically what used to be called cardinalities. Basically the number of items that can be related to another. So for multiplicities, we can not only relate how many, but we can basically define the minimum and the maximum number of times one class instance can be related to instances in another class. So we go back to our customer example, and let's think of a class that is an actual transaction, a sale. So for one particular sale, we're going to be associated with one customer. So each sale is associated with one customer. But a customer may purchase multiple items from us, so one customer can be associated with many sales, many different actual sales transactions. So customer to sales would be described as a one-to-many multiplicity. So we'll talk a little bit more about that as we go. So when we think more about classes, what is a class? What are examples of a class? Classes can represent a number of different things. Organizational resources, people, or organizations. And in this case, we mean organizations outside our organization. They can also represent events. So business transactions. For example, we could have a bank account as a class. And in general, we would just associate that in a very basic class diagram as bank account. In a more detailed class diagram, we're going to start like we have over there on the right with the bank account, basically the class name up at the top. And then we're going to also describe some of the key attributes in this bank account. In a fully documented class diagram, we'll have them all listed out. So we might have account number, and we're even going to define what type of data that is. Text or string for you computer programmers. Another thing we're going to have for the bank account is what's the current balance. That would be another attribute. and that's going to be a number, and a specific type of number that we have in programming is a currency. So a currency is just a decimal number that is defined in a system at 2 to 4, or sometimes in some cases more decimal places for calculation and reporting purposes. And then in our class, we may also describe some of the various activities, the events that can take place. So we'd have a deposit, and we even talk about some of the fields, some of the attributes associated with that. So an amount, currency, and then withdrawal, again with amount and currency. So the class diagrams, we start fairly high level, but we add detail to them as we continue developing the class diagrams until we have enough information that we can actually build a database. So the associations once we have multiple classes set up, we can start defining how they associate or how they're related to each other. So relationships between classes. And we can start, let's think of a car example. So we've got a class that's going to be called auto. We've got a person. We've got a dealer. And we have a state, or we might even say state DMV. A person is associated with an auto. A person is going to own an auto. An auto is going to have a primary owner. The automobile is going to be serviced by a dealer. An auto might be licensed in a state. So these rectangles, again, these are classes, and these are associations. The relationships between. So we have an auto that's serviced by a dealer, it's owned by a person, it's licensed in a state. So the final piece of UML diagramming for this section are associations. So we'll start with just one piece of that last diagram. Person, auto. And as we've talked about it before, a person owns an auto. You probably know some people that own more than one auto. You may know some people that own 0 autos. So that's the nature of determining these associations, the multiplicity of these associations. The notation for the auto side, we indicate what the minimum number of autos a person could own and what the maximum number is. So in this case, we would write a 0, and then a colon, and then an asterisk. So that asterisk indicates many, up to infinity, 0 to infinity autos. However, each auto is going to be owned by one and only one person. Each auto is going to have one owner. So this would be considered a one-to-many relationship, and it's the type of one-to-many relationship where there could be 0. Now there are some one-to-many relationships where there could be a minimum of 1. So the type of relationship is indicated by those numeric notations at each end of the association lines, and it also gives you some insight into the business rules for that organization. So what are some of the multiplicity options? Well, we've got 0, 1, so that's going to be 0 or 1. We've got 1, colon 1, which, like the person over on the left diagram, is only 1. We've got 0 and an asterisk, so that could be 0 or more. And then we also have possibility of 1 asterisk, 1 or more. All right, so that's a pretty good start for class diagrams. We've talked about the classes themselves, the associations, and we got started on multiplicities.